Hi guys, it's me, Mr. Emray, back at it again for differentiation part 2. The return that everybody wanted. This return gets 5 big booms. No big booms. So, today I will teach you what stationary points are. I will teach you what a maximum is, a minimum is, and a point of inflection. Now, you've probably heard of a maximum. Where's this? A minimum. And a point of inflection is when it just goes flat for a really short time, like this. Imagine it's going up, and yeah, it goes flat for like, yeah, it's like, I kind of missed. Whatever. So, what do all of these have in common? dy dx equals 0. Our gradient function is always 0 because it's a flat line, as you can see. Now let's do an example. Imagine it says, find the stationary points on the curve y equals 2x cubed minus 3x squared minus 12x plus 5. What do you first need to do? Step numero uno. Differentiate it to find the gradient function. dy over dx equals 6x squared minus 6x minus 12 plus nothing, as you learned from the last video. It will pop up here in like 5 seconds. I don't know, maybe it already popped up. Yeah. So as you can see, we have just differentiated, which is pretty cool. Now what you need to do is make it equal to 0. So it'll be 0 equals 6x squared minus 6x minus 12. Now you might be looking at this and goes, oh, I know what that is. That is a quadratic. And yes, you would be right. It is a quadratic and it will help us a lot. Now all we need to do is solve this quadratic, which gives us, before we even solve it, we can factor out a 6, which will give us x squared minus x minus 2 equals 0, which makes it very easy to solve, giving us x minus 2, x plus 1 equals 0. This means that our x is either equal to 2 or x equals minus 1. Now what do you do? All you need to do is put it back in our original equation. What was our original equation? Y equals 2x cubed minus 3x squared minus 12x plus 5. Let's start off with the 2, where it will give us 2 times 2 to the power of 3 minus 3 times 2 to the power of 2 minus 12. That's an x times 2 plus 5. Beautiful. Which gives us 16 minus 12 minus 24 plus 5, which equals minus 15. Now let's also do this for our x minus 1. So let's just label that as when x equals 2, y equals minus 15. And let's do it again. Y equals 2x cubed. It's always good to write it out in exams, so we won't get confused. Y equals 2 to the power minus 1 cubed minus 3 times minus 1 squared minus 12 times minus 1 plus 5, which ultimately gives us minus 2 minus 3 plus 12 plus 5, minus 1 minus 1, yeah, equals 12. Amazing. Oh, this is minus 2. Why did I write that? Yeah, minus 2, minus 3, plus 5, and 12. Because, yeah, addition. This means that when x equals minus 1, y equals 12. What does this mean? That our turning points of our cubic, because there's 2 turning points, maybe, yeah, there is 2 turning points, gives us 2 minus 15 and minus 1, 12. These are our turning points. You have found stationary points or turning points, either way you want to call them. Right. Now you might be asking, but I have the turning points, but I don't know if it's a maximum or minimum. Great question. All you need to do is differentiate it again. Oh yeah, let me do that. Oh, I forgot that I'm the one teaching. Sorry about that. And I've lost it. All right, let's do a new question then. E.g. Imagine you have the stationary points of a curve as minus 1, minus a third, and 3 and minus 11. And what is your equation, you might say? Well, I'll get to that. Calm down. Our dy dx is x squared minus 2x minus 3. And it'll probably ask you to determine the nature of each stationary point. It only says that because it's just saying, is it a maximum or is it a minimum? But it has to sound smart because you're in year 11 now. Grow up. Well, let's start this question. To find the second derivative of this, you just do d2 d to the power of 2 y over dx to the power of 2. Looks pretty cool, doesn't it? Equals 2x minus 2. Now, before we go any further, I just want to make it clear that if d squared y over dx squared is larger than 0, it means that this point is a minimum. If it's less than 0, it's a maximum. Now let's continue with our question. That equals that. Now all we need to do is take our x values and put them in. So when x equals 3, all we need to do is d2y and dx2 equals, put in 3, so it's 6 minus 2, which is 4. And as you can see, 4 is larger than 0, so this point is a minimum. I'm not waiting for you guys to say it out loud. And when x equals minus 1, it's minus 2, which equals minus 4. So it's less than 0, which means that it's a maximum. Yeah, you did it again. This is differentiation part 2. There will be differentiation part 3. And that will explain how you can find it by using the gradient. So you're going to have to use 3 values, and you're going to see negative, 0, positive. It'll be a saddle point. If it's positive, saddle point. And then, yeah, so on and so forth. Goodbye for now. I'll explain it in a later episode.